why is it that if you divide 1 joule by c squared, you get the magnitude of c squared?
You finally flipped.
I apologize. It was a bit of a circular logic question there. It's like, well, the speed of light that like about 300 million meters per second, that maximum of speed is defined in meters per second. That means that this 1 meter and 1 second are literally used to define it. These are our reference ones of measure, the units themselves, the second, the meter, the coulomb, the kilogram, and the Kelvin. Could you frame it a different way? Sure. But as long as you have this coherent system, as long as you can go from force equals mass times acceleration, energy equals force times a unit of distance, and then power is that energy per unit of time. That's why as you're checking to see how much battery is there, yeah, you're going to need to draw so much energy from your phone, your computer or something, and then depending on how much time you have left, it's going to be how much time your phone or your laptop battery has. We do this stuff all the time, it's just we don't necessarily think about it in a formalized framework because it's like, oh, math, oh, that's scary. I think we get to do a much better job, and again, it's part of it is perhaps the way education is. Being a teacher is hard. I went to school, I remember I had more than one teacher that at least had like mental breakdowns. And a lot of times you like say, oh, well, it's the teachers. It's like, I remember being a kid. I was a terror. I can understand that. So I think a lot of this is going to be hopefully some big updates to the education system and hopefully just making things more accessible, hopefully making things fun. That's the thing. Because you can teach somebody all the stuff in the world, and even if they can do it and they pass the test, it's, I don't know, maybe am I the only one that's like, all right, you need to learn this stuff for the test, blah, 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 blah. Okay, you do okay on the test and everything. You move on, you forget everything. It's like, well, what the heck was the point in that? It's like, oh, I passed the test. Why? So I could get a piece of paper. Okay, does this piece of paper help you? Hopefully it does. That's what we've been told for years and everything. I'm sorry, I'm going on to a rant here, but the whole point is that these constants of nature we have, whether it's the speed of light, whether it's an elementary unit of action, whether it's the Newtonian gravitational constant, Boltzmann's, these things are set up within a coherent system. Is that once you have these bases that you can go back and forth with in this framework, that we have a coherent system of units, might we be able to use it and literally be like, all right, humanity has done really well. Can we gain additional insights? Okay, so right over here, we have the joule. And let me set this because this is how it's defined. It is equal to 1 kilogram times 1 meter divided by 1 second. That whole dang thing is squared. Okay, so we have our 1 of energy. Okay, so if we have that, could we do something fun with it? All right, so again, this is going to be some catch up for some other folks, and not always the high fructose delicious kind. All right, so let's do something silly here. All right, so we got a joule, so let's look for something. So let's look for, we got a kilogram. All right, so we got a kilogram. How about, it's like the blank mass. It's this little thingy over here. It seems to be a maximum amount of mass you can cram into a Planck volume. So this would be a Planck length, just raised to the 3rd power, because if you have a length, you're going to make a square after that, and then you're going to make a cube. So you have a unit of volume. All right, and that's the maximum you can do there, so let's do that. Let's do the m sub p. M sub p. Okay, now we've got 1 meter divided by 1 second, and that's all squared. All right, so we've got a length, we've got a time, okay, and that's squared. So what if we took a similar framework, and since it's about the radical powers being unleashed. Okay, let's do just that. So we got a length, we got a time, we got an exponent, so we got that squared. Well, what if we took some other components rather than a length? Let's see what we got in our building blocks. Oh, look, h bar, the elementary unit of action. Let's take that. So let's take h bar, so we're going to take h bar, our little thingy over there. All right, so we're doing division in here. That sounds good. Let's follow that out. So we'll divide it by, what can we divide it by? Well, we've got these dimensions of measure here. So we've got the limits versus the references. So h bar, the elementary unit of action, that is expressed in the dimensions of action. Have you ever heard of the principle of least action? Well, that's action. What is that? It's energy times time. So basically, you got some energy, and then it's doing some stuff over a unit of time. So you got some energy, so if you're going to fire off your Kamehameha wave or something, it's going to... Okay, that's not a... Okay, I'm going into some different things. Maybe that would be power because there's a distance in there. So basically, it's energy acting over time. All right, that is your action. Now, the unit of energy is the joule. Okay, so we have the joule. So how about this? The joule per second. Joule second. That's its dimension. So we're going to do big J, small s. I'm going to take this whole thing, and then, well, rather than raising it to the second power, let's do that whole square root thing. And I realize I wedged the Planck mass in there. I apologize. Let me write this in a more succinct notation. All right, so we got m sub b, the Planck mass, and then let's just do the radical of h bar divided by the joule second. So, wait a second, this is different. Yes, it is. We're taking a mass and a mass. Rather than taking a length, we're taking the elementary unit of action. We're dividing it by the reference of action, the joule second. And then kind of like over here, we're taking the radical of that. We're taking the square root. Why? Because if you have a dimensional thing divided by the same dimensional thing, you're going to get a dimensionless thing. And then when you get a dimensionless thing and you multiply by a dimensionful thing like mass, you're going to get out, well, in this case, I claim you get out the mass of the Higgs boson, m sub big H over there. Okay. Now, this, some folks might say, oh, okay, that makes sense, but if you spent time learning like modern physics and stuff like that, this shouldn't make sense. Why shouldn't this make sense? Because, well, there's no way to calculate the mass of the Higgs boson, aside from going through these intervals of trying to account for all this energy, going out to infinity and trying to cancel it out and everything. There does not exist a succinct way to calculate the mass of the Higgs boson. Now, I'm not going to say, I'm claiming that's going to equal the mass of the Higgs boson. Why? Because it originally matched by like 3 significant digits, and then CMS's, CERN CMS project, the compact muon solenoid, actually released a paper, I think about the past month or so ago, and they had a current recommended measurement or calculated mass of the Higgs, and that was at. So, all right, so we got measurement. We'll do it over here. It's our little box. So measurement, prediction, because that's what we want to do. We want to predict things. Why? Because it makes us feel like, I don't know, we're oracles or something. It's wizards. Who knows? So, according to CMS, I'll put them in here. CMS, they actually won the Breakthrough Prize recently. I would say well deserved. And that they came back with a measurement of 125.38 GeV. That's giga electron volts. So roughly, it's about 125, 130-ish protons. That's basically the mass equivalence there. Okay. All right. According to this prediction, if we took it for what it's worth and we take all the numbers from CODATA and everything, we plug them in here, you're going to get out a mass, and again, this is expressed in energy equivalence just because it's easier for me to remember. You get a prediction of 125.376 with an error of 2 in the last digit, meaning this 125.376 could be 0.378, could be 0.374 GeV. And that puts us difference of 4 mega electron volts, MeV. The reason that's interesting is these are giga. Now, for those of you that learned your exponential prefaces from Final Fantasy VII like me, when you summoned Bahamut, his attack was called Mega Flare. When you summoned Neo Bahamut, it was Giga Flare. When you summoned Bahamut Zero, it was Terra Flare. So Mega, Giga, and Terra. That was how I learned it personally. But all you need to know is it's 1,000 difference. So this giga electron volt is actually 1,000 mega electron volts. Because the difference here, we match up through the 5th digit over here. And actually we need to go to the 6th digit and it would be 4. So that would mean we got tenths, hundredths, thousandth place. So right now the current CMS measurement is within 4 mega electron volts, aka 2 standard deviations of our prediction. So again, doesn't mean it's true, but cautiously optimistic that maybe there's some there.
To see a world in a grain of sand, and heaven in a wild flower, hold infinity in the palm of your hand, and eternity in an hour.